welcome to today's session. Today's session we are going to discuss second order low pass filter. In the last class we have discussed first order low pass filter. Now continuation of that discuss the second order low pass filter, where we are going to study this second order in the sense 100% it will be 40 decibels per decade, that is decrease in the stop band. So 40 decibels per decade decrease in the stop band. If you observe this frequency response of a low pass filter, this is more steeper whatever it was there in first order low pass filter, which are 40 decibel per decade in the stop band, right? So now as in the last session in first order low pass filter, we have used a non-inverting amplifier. Now I am also again using a non-inverting amplifier. Now since it is 40 decibel per decade and the second order, as I have told you, we are going to make use of two RC components. So RC. So in the form of R2C2 and R3C3. Okay. You just see this is the one change from this RC component. One is connected to ground, another is connected as a feedback path. Okay. That is the only change which is going to have an effect of second order low pass filter. Okay. So let us consider this particular circuit for our analysis. Now I am going to analyze using two types of frequencies. One is at low frequencies, another one is at high frequency range. Okay. So now during low frequency, you need to understand the capacitive reactances of C3 and C2. So you know this 1 by 2 pi Fc, which we have already discussed in the last class. So during low frequency, what is going to happen? The capacitive reactance, the resistance of the capacitance is very high, due to which it is viewed as an open circuit, which I am going to show you like this. You can observe. Now you just see this circuit. This circuit is just a non-inverting amplifier, and you know what is the output of a non-inverting amplifier? It is V0 is equals to 1 plus Rf by R1 into Vin. Okay, so this is at low frequency. Now as soon as the low frequency changes to high frequency range, capacitance effect is going to start. Now what is that capacitive effect is? Now just see, now this capacitor slowly starts getting shorted, and this capacitor is shorted. Now what is the meaning of this is, you just see this is the first RC component which is giving you 20 decibel per decade in the stop band over here. So that means 120 decibel per decade is producing by R3 and C3, which is going to be called as phase lag mode. Now these two are in phase lag mode. Now you come to another one. Now this R2, R3 and C2, which was about to become short circuit, and these three will have effect. Now you just see it is connected to the output terminal, which is in the form of a feedback path coming at this particular junction of R2 and R3, which will have some effect. Now this will have phase lag. Now this will try to pull the signal towards zero in the sense it is going to be called as phase lead mode. Now because of this pulling and pushing, we are going to have 20 decibel, another 20 decibel per decade change in the stop band over here. Now due to which the first 20 decibel is due to R3 and C3, second one is from R2, C3 and C2. Okay. So now because of which I am going to get 40 decibel per decade. So this particular filter, whatever it is designed, is nothing but second order low pass filter. Okay, so now you came across designing over here. There is no such derivation, very complicated derivation is there for this. Instead of that, we will see the high frequency cutoff frequency formula is given as 1 by 2 pi square root of R2, R3, C2 and C3. Okay, product of R2, R3, C2, C3. Now if I am going to find the magnitude of this particular non-inverting amplifier acting as a second order low pass filter, so I am going to write it as AF divided by square root of 1 plus F by Fh whole to the power of 4. In first order it was F by Fh whole to the power of 2. Now it has been doubled. It is becoming whole to the power of 4. Okay. So now if we are going to analyze this with three cases, we will come across the same concept what we have discussed for low pass filter, first order low pass filter in the last class. Now in the design part, I am going to set R2 is equal to R3 is equal to R. I am going to choose C2 equal to C3 equal to C, which is always less than or equal to 1 microfarad. This is very important. Then R I am going to design this equal R 1 by 2 pi FH into C. Now when you come across the gain, non-inverting gain of the operation amplifier, I am going to choose this condition for RF, which is nothing but 0.586 into R1. Why? Because this particular circuit is designed for a gain of 1.586. Now in this 1 is nothing but 1 plus. Now this ratio is nothing but 0.586. Therefore RF is equal to 0.586 R1. Now R1 is always try to choose for this design as less than or equal to 100 kilo ohms. Okay. Now overall the second order low pass filter is having operation from low frequencies. Now R3 and C3 is going to give 20 decibel per decade. Another 20 decibel per decade is obtained from R2, R3 and C2 combination over here. Now this is the design part what we have studied. Now I hope you have followed the second order low pass filter. Okay. In the next session we will see what is high pass filter and different orders of high pass filter. Thank you.